Good day to one and all. Let us welcome for the today's session. Today we are going to discuss how metals reacts with non-metals. Yesterday or in our previous class we understood what happens when metals reacts with metallic salt solutions. And after understanding 3 to 4 types of reactions of metals with air, water, acid and the metallic salt solutions, today we are understanding how metals react with non-metals. Okay, this is the most important part of the chapter because here we are understanding reaction between metals and the non-metals on electronic ground. For this, we have to use the knowledge of ninth class where under the chapter structure of atom we have studied atom is breakable into protons, electrons and the neutrons. Then we have studied different atomic models. In that, more popular model was Bohr's, Niels Bohr's from Denmark, that model. And after that, we also understood in the ninth class how to write electronic configuration using KLMN theory. Okay, so using that knowledge of ninth class, today we are understanding how metals react with non-metals. Okay, so once again I welcome you all for the today's session on understanding electronic way of understanding reaction between metals and non-metals. This table I have taken from the textbook to discuss with you all. Okay, see, noble gases helium, neon, argon, chemically least reactive because they follow strictly either doublet rule or octet rule. So in chemistry, these two rules are called as the most stable rules. So any element which follows these two rules are chemically least reactive, and that is there only with noble gases. Okay, right. So that's why they are chemically least reactive. And if you atomic number also written here, and as per the KLMN, K can take 2, L can take 8, M can take 18, N can take 32 and so on. Okay, this is strictly according to the Bohr's theory 2n square formula. Please recall once again, I'm reminding you, ninth class. Okay, so atomic number 2, 2 electrons, so 2 in the K shell. Neon, atomic number 10, 10 electrons. K can take 2 only. So remaining 8 will go to the next shell, L shell. So 2 plus 8, 10 makeup. हो गया. Now argon 18. Okay, 18. See here, K can take 2, L can take 8 maximum. Then remaining 8 will go to the automatically M shell. Though the capacity of M is 18, but only 18 electrons are there, no? Because atomic number is 18. So when the what is atomic number? Atomic number is the number of electrons revolving around the nucleus or number of protons present in the nucleus. So when we have with us only 18 electrons, how can you go for more than 18? Therefore, already 2 we have given in the K shell, 8 we have given in the L shell, then only 8 will be there in the what M shell. That's why it is called 288 configuration for argon. And please see the outermost configuration for these three. So as per the doublet rule, this is stable. As per the octet, these two are stable. Therefore, they are chemically least reactive. Having 2 electrons in the only K shell and having 8 electrons in the outermost shell is there only with the noble gases, not with any other element. Okay, right. Now, sodium. Sodium. This is the configuration. Please check. Okay, magnesium, aluminum, potassium, calcium. All these are electronic configuration. So please go through this. So what? Why 7 came here? Atomic number is 7. Okay, right, not K. Okay, right. Okay, it's correct. So textbook table, no, correct print. Okay, right. So now I'll go with this table. How to understand or let us understand reaction between metals and the non-metal. Sodium metal with a 281, it prefers to lose electrons so that it acquires a 2,8. Once again, ninth class. Other elements except noble gases, they don't have 8 electrons in their outermost shell, but they want that type. Why they want? Because that is branded, that is taken as the most standard, most stable electronic configuration. Therefore other atoms wants to acquire. Okay, so other elements or atoms wants to acquire their nearest noble gas configuration. How they acquire? Either they have to lose, or they have to gain, or they have to share. So by doing any one of these three transactions, they will achieve the stable electronic configuration. But in the case of sodium here, only one is there. If one is lost, it becomes 2,8. Otherwise, it has to gain 7 electrons to become 288. Gaining 7 is easy, or losing 1 is easy. Losing just 1 is easy. Therefore, it prefers to lose electron, and after losing, 2,8 is the electronic configuration. Okay, right. I know one electron is lost here. Okay, right. Now this is called sodium cation. Why it is called sodium positive ion? Because earlier sodium was neutral, right? So when it is neutral, protons and electrons are equal. So 11 proton, 11 electron equal. Now 11 protons are here, but here one electron is lesser. So only 10 electrons are there here. So electrons are less, protons are more. By how much? By 1. So it is getting 1 plus. This plus indicates that which is more. Okay, plus is more. By how much? By 1. Okay, that is a what understanding, or that is the rule we have made in the chemistry. So sodium cation is formed by the loss of one electron from the sodium neutral atom. In the same way, now we'll go to the chlorine non-metal, metal and non-metal. So it is 287. If it want to become like noble gas, it has to lose 7 or accept just 1. So for chlorine, accepting 1 is easy. Okay, always they see shortcuts, easy method. So accepting 1 in the case of chlorine is very easy. Therefore, it has to go for accepting electron. So after accepting, it becomes 288. Earlier 17 proton, 17 electron, but after accepting electron, 17 proton as it is, but electrons are one more, that is 18. So here electron dominates by how much? 1. So because electron dominates, it gets the negative charge. Because proton dominates, it gets the positive charge, which is dominating that charge it gets. Okay, right. So this is called as what? Chloride anion. Chloride negative ion. Sodium cation. Sodium positive ion. Once they become plus and the minus, they start attracting. So sodium reacts with the chlorine, becomes sodium chloride in this way. Okay, right. The same way, see magnesium, loss of 2 electron, cation, loss of 1 electron, anion. Okay, so magnesium has lost 2 electrons. Where they'll go? So to accept the 2 electrons given by the magnesium, 2 chlorine has to be we require. So that's why 2 chlorine they have taken. So MgCl2 formula. Okay, right. Now this one is formation of magnesium oxide, 2A2 magnesium. It has to lose 2 electrons. Okay, so after losing Mg2 plus. Now these 2 electrons are taken by whom? Someone. Who is someone here? It is oxygen. Let us say oxygen. It is 2,6. Okay, to become noble gas, it wants 2 electrons. Okay, so it wants 2 electrons. Magnesium has already given 2 electrons. It will take 2 electrons. That means 2 given, 2 taken. But in the previous case, 2 given. Okay, but 1 chlorine wants only 1 electron. So to satisfy the magnesium's 2 loss, 2 chlorine has to come and accept the each one electron, so that MgCl2 forms. But in this case, in the case of magnesium oxide, magnesium lost 2, oxygen wants 2, equal MgO formula. Now in the case of calcium, in the case of calcium sulfide, okay, calcium sulfide, you see here calcium 20, atomic number is 20, 28A2, 28A2. It has to lose 2 electrons, so it becomes 288. Make it 8. Sorry, it is here only. So it has lost 2 electron, becomes A2 plus, right? It is called 288 configuration, stable configuration. Now sulfur 286. It wants 2. It has lost 2. It wants 2. No extra. CaS, calcium sulfide. Okay, so depend upon the how many electrons are lost, how many electrons are gained, formula is taken. This is one way. Another way is what? Another way is balancing the charges as per the ninth class. Okay, this is in terms of electronic way you can write down, or in terms of using ninth knowledge after forming the ion crisscross method, exchange the charges. That also we can go for the formula. So two ways both are allowed. So which way is easy for you, that you follow. Okay, so till then, bye, and the remaining part we'll discuss afterwards. Okay, bye and have a nice time.